This is our third lesson for the week, and in this lesson we're going to talk about dividing polynomials. So we had to save dividing polynomials until the end because part of how we're going to divide them is factoring. So we had to learn factoring first. I forgot to have it typed in the notes, but right here we're going to start with this because that's what we're going to see in our first two examples. If we're going to divide a polynomial by a monomial, in other words, we've got multiple terms on the top and a single term on the bottom, a monomial, we're going to just simply divide each term individually by that monomial. And that all goes back to fraction rules, that I could write this as negative 15x to the sixth over 5x as its own fraction minus negative 10x to the fourth over 5x as another fraction plus 5x squared over 5x as a third fraction. So just kind of fraction rules there as to why we just divide each term on the top by the one on the bottom. In other situations, we're going to see that we have a polynomial divided by another polynomial. And in those cases, we're going to have to factor both the numerator and the denominator. Factoring is the hard work. But once it's factored or once it's in factored form, we will simply cancel out any common factors. So any factors that are exactly the same on the top and the bottom, we cancel each other out because anything divided by itself is 1. Multiplying by 1 doesn't do anything. If you decide to do the spicy assignment, that assignment does not approach division in either of these ways. That one actually uses long division. So if you decide that you want to do the spicy assignment, that is fine, but it is an Algebra 2 topic, and you're not going to be tested on that. So if that is something that you choose to do, you're going to have to do a little mini lesson with me first. I also posted another video in Google Classroom of another teacher going over it, but you have to have my approval either way. So nobody can do that unless you've practiced dividing the way that you're going to be tested this year first. So let's get into our examples. So in this first example, this is a polynomial divided by a monomial. So I am just dividing each of these terms by 5x. So negative 15 divided by 5 is negative 3. X to the sixth divided by x is x to the fifth. Negative 10 divided by 5 is negative 2. X to the fourth divided by x is x to the third. 5 divided by 5 is 1. I'm not going to write it unless it were the only thing left. X squared divided by x is x, so I don't need that 1 as a placeholder. I have the x. And that's it. That is all I have to do. I just basically have to remember to divide each term by the coefficients and then subtract my exponents. Same idea even if I have multiple variables. So I'm dividing all three of the terms on the top by 3xy. So 3 divided by 3 is 1. X divided by x is also 1. Y squared divided by y is y. So I don't need to write the 1 because I do have the y. If this term and that term had been exactly the same and the whole thing had equaled 1, I would need the 1 as a placeholder. But in this case, it's just 1 times the y. I don't need to write it. Negative 9 divided by 3 is negative 3. X squared divided by x is x to the first. Y divided by y cancels out, it's 1, so that's all that's left there. 21 divided by 3 is 7. X to the third divided by x is x squared. And y to the third divided by y is y squared. So that's my final answer, except it's not in standard form, so I need to rearrange it. So alphabetical order first and descending exponents next. So the x comes first in the alphabet. Highest exponent on x is 2. So the 7x squared y squared is first. This term also has an x, so it has to come next. And then the y is at the end. So that is my final answer in the best possible form. I forgot to talk about that on the first one, but we only had x's and they were already in descending order, so we were good. For these last 4 examples, we're going to have to do factoring before we can do any division. So I'm going to have to factor both the numerator and the denominator, and in both cases I have a leading coefficient that is greater than 1. So you can choose whichever method you want to factor. You can do guess and check, you can do slide and divide, you can do the factoring by grouping. I'm not necessarily going to talk about how to do the factoring of these because that was in lessons A and B, but the factored form of the top is 2x minus 5 and x plus 3. The factored form of the denominator is 2x minus 5 and x minus 2. Once I have these in their factored form, which again, the factoring is the hard part. Once they're in the factored form, you just look for any factors that are the same on the top and the bottom. So this binomial 2x minus 5 is being divided by the binomial 2x minus 5. They're both in parentheses. So since they're both in parentheses, they're like an entire unit of something that's being multiplied, and so they can cancel each other out. And the division leaves me with x plus 3 over x minus 2. And that's my final answer. In the next one, I'm not going to have to factor the bottom. That's as simplified as it can be, but I do have to factor the top. So I have to think about factors of 7 that add to 8. So that factoring's not too hard. Remember, denominator in and of itself is a grouping. So if I want, I can put parentheses around it. And since the grouping x plus 1 is on the top and the bottom, that same binomial appears. These two cancel each other out. And when I divide, I am left with x plus 7. And that's my final answer. The last two examples, I have written these division problems in some different ways, just to make sure we know all the different ways we could see things. So this one has it written with this kind of standard division symbol, but this means the same thing as 3x squared minus 22x plus 7, all divided by x minus 7. So I can rewrite the problem if I like it kind of in this more fraction format. Still, don't get to avoid factoring the top. Now, I will give you a hint as far as where guess and check can sometimes be a little bit easier on the division problems. All the division problems that you're going to see in Algebra 1, you're going to have a common factor between the top and the bottom. So I can almost bank on the idea or the fact that one of the factors of the top is going to be x minus 7. And sometimes that can help you if you want to factor just using the guess and check. So as it turns out, 3x minus 1 is one factor, x minus 7 is the other. If you don't feel comfortable with guess and check, remember, you can still do slide and divide or factoring by grouping. You're going to end up in the same place either way. So these two are the same, they cancel out, and I'm left with 3x minus 1. So one thing that we notice in this, I still had a factor on top and bottom, so I was left with a fraction. But in some of these, I only had one polynomial in the denominator, and so when things cancel out, I'm just left with a polynomial, not a fraction of polynomials. So your answers can look either way. In this problem, this is supposed to be one of those long division symbols, but didn't quite have the right, kind of looks a little weird. But anyway, so this is a long division symbol like you would have seen back in maybe like 4th and 5th grade. And remember, when we write division this way, this part here that is underneath the dividend is what would be on the top of the fraction. And then the divisor is the part that's out in front. So that's what would be on the bottom of the fraction. Now when I go to rewrite this one though, I don't want to write this one the way that it's written. I want to rewrite it in standard form because it's going to make it easier for me to factor it when it's in standard form. Oops, plus 8. And so again, use whichever method you prefer. You could also factor out a negative in your numerator first, but when you're done factoring, you're going to have that as your numerator, and your denominator is n plus 2. So the n plus 2 is the same in both places, leaving me with negative 3n plus 4 as my final answer. So that is division. So the division itself, not very complicated. The part that makes it not exactly easy is that you also have to factor still. So those are all of the lessons. Please make sure you choose at least one assignment on the bottom to practice dividing polynomials. And I really want everyone to choose either the mild or the medium. So I want you to get some practice with the division like this. The spicy assignment is good if you really need a challenge, if you have found factoring super easy, but I'm not going to let anybody just skip straight to that one because it's not what we're being tested on. It's taking it a step further.